everyone. This is the first recording that I have done for your class, Algebra 1. And in this video, I'm going to talk about section 3.1. So I'm going to kind of go through this quickly since we've already talked about this in class. This is just meant to help you review a little bit and maybe refresh on anything that you might have missed during class. So feel free to pause this video at any point in time, go back, play it over. If you pause it while I'm working a problem to see if you can do it, so forth. That's always a good strategy. So I'm going to start first with identifying linear equations. So the only things that kind of disqualify something from being linear are anything that will make it not a line. That's where the word linear comes from. And I know you guys haven't studied a lot of graphs yet, but these exceptions come from things that aren't lines. So if something is non-linear, that means it will not look like a line on a graph. And things that do that are if you see exponents or square roots on either x or y. Another thing that will disqualify an equation from being linear is if you see x and y next to each other. In other words, they're being multiplied, not added. That's not allowed for a linear function. Another thing that's not allowed for a linear function is if you are dividing by x or y. And the reason why that's true is because it's actually a variation of this guy. So if you see something like 1 over x or 1 over y squared, it doesn't even have to be a 1. It could be 3 over x. Anything where you're dividing by a variable, that's not going to be linear. The only exception to that case is if this is kind of equal to a number. So this is rare that you'll see this as far as when I would ask, but if you see something that looks like y over x equals a number, this actually is linear, because if I solve for x, and we learned how to solve for x or y, actually I want to solve for y, I'm going to have to multiply both sides by x. What that does is the x's will cancel, and you're left with y equals 3x. Well, that is linear. So if you see y divided by x, that is linear. It's only when you're dividing by like a number divided by x or a number divided by y, then that's not okay. So I believe that's all the ones that we talked about from making it non-linear. Next, let's talk about standard form. So standard form is if it is linear, then that means you can always put it in standard form. So to repeat that, if you decide that it is linear, then you can put it in standard form. And standard form is ax plus by equals c, where a, b, and c are coefficients. That means they're numbers. So you actually see numbers in their place. But there are certain rules about a, b, and c. So a can't be negative. A and b, actually a, b, and c cannot be fractions or decimals. So the reason why I say fractions or decimals is because I typically say fractions, but then some kids try to get sneaky and say, well, I'm using a decimal, but you guys learned in middle school that fractions and decimals are really representations of the same thing, unless it's irrational, which we talked about in chapter 0. So anyway, these cannot be fractions or decimals. So if you're breaking either one of these rules, then we have to rearrange the equation. Also, you should notice that x and y are on the same side. They're both on the left side. So if an x or a y is on the right-hand side, you need to move it to the left. So for example, we'll just do 2 of these. If you see y equals x plus 3, so we'll start really basic. If you notice, the x is on the right-hand side, so I need to move it to the left-hand side. Well, if I subtract x from both sides, I'm doing minus x, and if I put the x in the front, I get minus x plus y. So I'm trying to graduate you guys from writing every single step. So hopefully you see that. But just in case you didn't see that, what I did was minus x, but this is a plus y in front here, so that's how I got minus x plus y. Well, if you notice, now we're breaking a rule. We're breaking the rule that this coefficient can't be negative. So to get rid of that negative, we're going to multiply the entire equation by -1. And I know it's not technically mathematically correct to write these parentheses like this, but it helps us see what we're doing, so I'm okay with that. -1 times -x, negative times negative is positive. -1 times y, don't forget we have to distribute, is -y. And don't forget the right-hand side. So if you really want, you could put the parentheses in here, and this is the mathematically correct version I was alluding to. I can multiply this side by -1. And so this ends up being -3. So this would be your final answer for standard form. I have no fractions or decimals, and my a value, my coefficient of x, is positive. So let's do a second example. This time we'll deal with the fraction stuff. So another example would be, let's see, y equals 2/3 x minus 5. So we are breaking a couple of rules here. One, notice how x and y are not on the same side. So we have to move this 2/3 x just like we moved the other x before. So we're going to get -2/3 x plus y equals, and don't forget that this negative here with the 5 stays with the 5. So this is -5. Now, let's figure out how to get rid of this fraction and this negative sign in front. When we already know how to take care of this negative, we're going to multiply everything by -1. But we need to figure out how to get rid of the fraction. You may have had a good idea of multiplying by the reciprocal, but if you multiply by 3/2, then your coefficient for y will be 3/2. And that's a fraction, so that doesn't work. So instead of multiplying by the reciprocal, we're going to just multiply by the denominator, this 3. So I'm going to multiply everything by -3 to get rid of the negative and the 3 at the same time. -3 times -2/3, the 3 and the third will cancel, and negative times negative is positive, so I get 2x. Distributing -3 to positive y, I get -3y. And multiplying -3 times the right-hand side, -5, I get a positive 15. So this is your standard form for the fraction situation. So the reason why we learn standard form is because it makes it super easy to find the x and y intercepts. So actually, let's take this 2x minus 3y equals 15 and find the x and y intercepts and then graph it. So I'm going to go over to the next page. And our equation is 2x minus 3y equals, was it negative or positive? Positive 15. And I want you to find the x and y intercepts and then graph it. So to find the x-intercept, we always know that for the x-intercept, that the x is actually a number and y is going to be 0. So we're going to set y equal to 0. And so we get 2x minus 3 times 0 equals 15. Well, 3 times 0 is 0, so that term just entirely disappears. So we get 2x equals 15. Divide it both sides by 2, and x is 15/2, which is the same thing as 7 1/2, or if you really want, you can write it as a decimal, 7.5. Regardless of how you write it, this is a point. I don't want you to think that it's just a number. It's a point with a coordinate of 7.5, comma, what's the y value? We set it equal to 0, so it's 0. So that is going to be one of the points that we put on our graph. Now if we look at the y-intercept, just like the x, we have a y value and the x is 0. The reason for that is if you think about your graph, the y-intercept is here. Well, we didn't go anywhere left or right. That's why x is 0. The x-intercept is here. We didn't go up or down. That's why the y is 0. So always think about why you're doing these things, not just what to do. So set x equal to 0. And then from there we get 2 times 0 minus 3y equals 15. Well, just like before, 2 times 0 is 0. This term disappears. Don't forget that this negative stays with the 3y. It doesn't disappear with the 2 times 0. So you get negative 3y equals 15. And so y, if we divide both sides by negative 3, we get 15 divided by negative 3. Positive divided by negative is a negative 5. And again, I don't want you to think that this is just a number, negative 5. This is a point. It's the y-intercept. It's a point. And so the y value is negative 5. And the x, well, we set it equal to 0. So it's 0. The reason I'm being very particular about these 2 points is because a lot of students would make a mistake of saying this is the point 7.5 comma negative 5. That's not true. They're 2 different points. Don't combine them. So now let's go ahead and graph these. In geometry, I know you're not there yet, but you kind of have this notion in your head. If you have 2 points, there's only one line that goes between them. So we have 2 points. We can draw the linear function by just connecting them. And so if I can get a graph going, sorry, bear with me for a second. Passed it. Our 2 points were 7.50, so I'm going to go here. 7.5. 7.5 is exactly halfway between 7 and 8. So I'm going to find 1, 2, 3, 4, 5, 6, 7, 8. Well, here's the halfway point. This is the point 7.5, comma 0. If I go back to the other slide, 0, negative 5 was our y-intercept. So 0 in the x direction means don't go left, right. Negative 5 means go down 5. So 1, 2, 3, 4, 5. Looks like I just barely get by with my graph here. 0, negative 5. Now I'll take a ruler and connect those. So I don't have a ruler on me, but you would use your ruler to draw this really, really well. And so that's how you use your x and y intercepts to graph a function. You should also be able to find x and y intercepts from a table. And so I just want to look at the example number 3 on page 155. So if you don't have your book open, maybe pause this and open 155. If you look at this, there's a pool example. And there's a table where they give you points, time in hours, and the volume of the pool in gallons for that time. So if we're looking for the x-intercept occurs where y is 0. Well, if you look at that, that's the 14, 0. I want you to understand what this means. This means that for 14, well, what are the units on 14? The units are hours. And the 0, what are the units on 0? If you look up, it says gallons. That means that after 14 hours of draining the pool's empty. After 14 hours of draining the pool, the volume of the pool is 0 gallons. That means it's drained, it's done. So it took 14 hours to drain this pool. If we look at the y-intercept, that's where x is 0. That's the very first value, 0, 10,080. Well, let's think about what that means. 0 has units of hours, and the volume has units of gallons. So at 0 hours, in other words, what we start at, there are 10,080 gallons in the pool. So there's a lot of water in that pool. So the y-intercept, what that means is the y-intercept is like your starting value. And we'll start to understand this more when we talk about slope-intercept form. But the y-intercept is your starting value. The x-intercept is basically how long or how far or something like that until your y value is 0. And so make sure you understand the check your progress number 3 is a great one to look at. And so if you're doing that, pause this. The answer for check your progress number 3 is that the x-intercept 4 means that after 4 hours, the Torres family arrived at the amusement park. The y-intercept means that their house is 248 miles away from the amusement park. So hopefully you understood that. That's all you need to know for really this section. I know in example 5 it talks about graphing by making a table. I'm going to talk about that when we are in the 3-2 video. So we'll get that tied into the other stuff.